Exercise 7.2 Problem 13 Discussion. Let's read the problem. A boy standing on the ground spots a balloon moving with the wind in a horizontal line at a constant height. The angle of elevation of the balloon from the boy at an instant is 60 degrees. After 2 minutes from the same point of observation, the angle of elevation reduces to 30 degrees. If the speed of wind is 29√3 meters per minute, then find the height of the balloon from the ground level. Okay, so let's make a very simple diagram. So this is the boy, and this is the first position of the balloon, and this is the second position of the balloon. So from here he looks up, okay, and this is a horizontal line, horizontal line, and this is a line of vision. So this is the angle of elevation, 60 degrees. Then when he looks up at this particular point after 2 minutes, the angle of elevation is 30 degrees. Okay, this is 30 degrees. So drop a vertical line here and drop a vertical line here and join. This is a ground level. AE is the ground level, and BD is the B is the initial position of the balloon, and D is the final position of the balloon. A is the boy. Now the balloon was here, okay, at the first instant, and the wind was there which is moving at the speed of 29√3 meters per minute, and this wind actually it goes with the wind, so the balloon moves with the wind speed. Okay, so the speed of the balloon is equal to the speed of the wind, so that is 29√3 minutes, and it takes 2 minutes for it to reach D. So which means this distance BD equal to speed into time. Okay, so speed into time will give you this distance. So we now know the distance moved by the balloon, and we are asked to calculate the height of the balloon from the ground level. Okay, anyway, let's mark what is given. So the initial angle of elevation is 60 degrees, final angle of elevation is 30 degrees. It takes 2 minutes to move from the initial to final position. The speed of the wind is 29√3, and we are asked to find the height of the balloon from the ground level. Okay, now in this triangle BAC, if you take tan 60, that is opposite by adjacent, then you will have a relationship between BC and AC. Both we don't know, but we want to know BC. BC equal to DE. Both are the height of the balloon from the ground level. Okay, so you'll get a relationship between BC and AC. Then this triangle ADE, okay, tan 30 is opposite by adjacent, right? So that is DE divided by AE, right? But what is DE? DE and BC are equal, so you can write this also as BC divided by AE. You will get another relationship. Then you have to get there's one more relationship, AC plus CE equal to AE, right? And what is CE? CE is BD, which is 29√3 into 2 minutes. Right? So using these three conditions, we will be able to calculate the height of the balloon from the ground level. We'll work it out. This is little complicated, but we can solve it, nothing to worry. Okay, so let's list what is given in the problem. The speed of the wind is given 29√3 meters per minute. Angle of elevation is 60 degrees and 30 degrees. This is the initial angle, and this is the final angle. The time taken for it to move from initial to final is 2 minutes. What are we asked? Height of the balloon from the ground level. And typically it is tan theta, because this is relationship opposite to adjacent. So this is the relationship which we will be using. So tan theta is the formula which we will be using here. So step 1, as usual, draw a rough diagram, label and mark the diagram with the given values. Step 2, calculate the distance moved by the balloon in 2 minutes. It was originally here, and it moved from here to here in 2 minutes. And what is the speed? Speed of the balloon is nothing but speed of the wind. Okay, so that is how we should take. Speed of the wind is 29√3. So distance equal to velocity or speed into time. So 29√3 into 2 minutes, and see, this is also in per minute, so this is also in minutes. Suppose this is given hour, you need to convert this to hour. Okay, or if it is in seconds, this needs to be converted to seconds. Please be careful about the units. The consistency of the units is very important. Okay, so this is 2 minutes, this is also per minute, so everything is fine. So 29√3 into 2 will give you the distance. What is the distance? BD or CE, because BD equal to CE, right? So we have now calculated the distance moved by the balloon. Now in the triangle BAC, tan 60 equal to opposite by adjacent. So that is BC by AC, right? So now we are getting a relationship. Tan 60 we know, so you will get a relationship between BC and AC, okay? Or we will get AC in terms of BC, okay? Because this is known value, right? That's first one more step. Then step 4. In DAE, now what else? This we have already done, okay? So this is another information which we have. We need to work on that, right? Tan 30 is in this triangle. DAE is opposite by adjacent. That is BC by AC. You might be thinking why I am using BC. It is actually DE, right? But DE equal to BC. We want to get everything in terms of all these distances in terms of BC, then only we will be able to calculate it. So actually tan theta is DE divided by AC, but since DE equal to BC, I am writing it as BC by AC. Then substitute the value of AC, AE and BD, which is equal to CE. This BD equal to CE. Please be careful, this equal to this and this equal to this, right? Then what is AE equal to AC plus CE. So you substitute everything. AC we just got in the first equation in terms of BC. Now the next is the BD. DE. DE also we just got it in terms of BC, right? Because tan 30 is BC by AC. So you will be able to get the AC in terms of BC. So now AC is also in terms of BC and this CE, right? AE is also in terms of BC. And what is CE? CE equal to BD. What is BD? BD is 29 root 3 into 2 minutes. This is the distance traveled, right? So this we know, okay? This is written in terms of BC. This is also written in terms of BC. So you will have an equation in BC, which means you will be able to solve BC. Right? And what is BC? That is what we want to find. That is the height of the balloon from the ground. Okay. So let's pause it here. Let's keep continuing and we'll go to the solution. So let A, B, D be the first boy, first and the second position of the balloon. This is the boy, the first position of the balloon, and this is the second position of the balloon. So given angle of elevation BAC is 60 degrees and DAE is 30 degrees. What is BAC? From here is looking at the balloon. So this is the angle of elevation, right? This is a horizontal line or horizontal, okay, it's a horizontal position, okay. So this is 60 degrees. Then this is DAE is looking at the final position, okay, that is the angle of elevation in that case is 30 degrees. So that is what it says, DAE is 30 degrees. Now, the speed of the wind is given as 29 root 3 meters. And the distance traveled, so initially he saw the balloon here, and after 2 minutes he is seeing the balloon here. And that is when the angle of elevation changes from 60 degrees to 30 degrees. What is the distance traveled? BD is speed into time, because the balloon travels at the speed of the wind. Whatever is the wind speed, that is the speed of the balloon. So, distance traveled by the balloon in 2 minutes is speed, okay, into velocity, into time, I'm sorry. So 29 root 3 into 2, okay. So probably I should write the formula here, distance equal to speed into time, okay. So that will be useful. We'll do that a little later. So 29 root 3 into 2 is 58 root 3 meters. Now that part is done. Now let's work out the relationship, get everything in terms of BC. Okay, what is tan 60? Opposite by adjacent. So which means tan 60 is root 3, right? So BC by AC is root 3, or BC is equal to root 3 AC. So this is one relationship. Okay. Oh, I'm sorry. BC by AC is root 3. So AC will be BC by root 3. Sorry. Because this goes up and root 3 comes down, right? So AC equal to BC by root 3. Multiply both the numerator and denominator by root 3. You will get BC into root 3. Root 3 into root 3 is 3. So AC equal to root 3 BC by 3. This is equation 1. Now come to triangle DAE. Tan 30 is opposite DE divided by adjacent, that is AE, right? Tan 30 is DE by AE. So DE by AE equal to tan 30. What is tan 30? That is 1 by root 3. Substituting that, you will get this. Now we will have to get AE, right? So AE will be equal to DE into root 3. So AE will be equal to root 3 into D. Just cross multiply, it will go up. Okay. So AE equal to root 3 DE. But what is DE? If you look at the figure, DE and BC are equal. So we can write AE as root 3 BC. Okay. Now we have AC in terms of BC as per equation 1, and we have AE in terms of BC as per equation 2. And what is AE? AE is AC plus CE. And what is CE? CE is BD. And BD, we know the distance moved by the balloon is 58 root 3, because we did that calculation, right? Remember, speed into velocity, speed into time. Okay, 58 root 3 meters. We did that in the previous slide. So substituting all these things, equation 1, 2 and this information, we will get, okay, AE is what? Root 3 BC. AC is what? Root 3 BC by 3, right? So I'm just bringing it down to this side. So it becomes AE minus AC equal to CE. What is CE? We just saw CE equal to BD, that's equal to 58 root 3. We have one equation in terms of BC. So we'll be able to calculate it, right? But before calculating it, let's make life simple. So divide both sides by root 3. Root 3 is common. So this will go off, this will go off, and this will go off. So you will get BC minus BC by 3 will be equal to 58. And BC minus BC by 3 is 2/3 BC. Taking LCM, you will get that. 3 BC minus BC by 3. 3 BC minus BC is 2 BC by 3 equal to 58. Now what is this? So BC will be equal to 58 into 3 by 2. And 58 into 3 by 2, 2 will go 29 times. So 29 into 3, 87 meters. Therefore, the height of the balloon from the ground is 87 meters. You got it? Previously, we used to have either this dimension or this dimension, and they will give you one angle, and we will use the relationship tan, sine, cos, whatever is applicable, and get the other side. But here they have given only this side, but they have given two angles. So using that, we are trying to find the height. Okay, so let me repeat. So using this triangle, you are getting using tan 60 equal to BC by AC, you are getting a relationship between BC and AC. This is what we got here, right? Then using this triangle, you are getting DE in terms of AE, okay? And DE is nothing but BC. So it's basically BC in terms of AE, right? That is what this equation. Then we know AE equal to AC plus CE. You are using all those values here. But what is CE? CE is BD, right? These two are equal. And what is BD? It is the speed into time, because the balloon moves from here to here in 2 minutes, and the speed of the wind is 29 meters, 29 root 3 meters. So 29 root 3 into 2, that is 58 root 3. So this is what comes here. And this is written in terms of BC, and this also is written in terms of BC. I've just taken it to the left hand side, I've written it as negative. Okay, that's all it is. Now you have everything in terms of BC. You can calculate BC. And BC is nothing but height of the balloon from the ground level. Okay, so this is how this problem needs to be solved. It looks complicated, but if you go through one more time, it will become clear. Thanks for watching this video.